Hello everyone, power and energy. Second leg of the topic work, power and energy class 11th. For you people, बता दें यार इट्स क्लास 11th ना. हाँ 12th वाले देखेंगे तो फ़ायदा होगा. फ़ायदा तो होगा. फ़ायदा तो होगा उन्हें भी. फर्स्ट वीडियो आई पोस्टेड अपॉन, याद है, वर्क, टाइप्स ऑफ वर्क, evaluation of work, different methods through which work can be evaluated. Today I will highlight you about these two headings, power and energy. एनर्जी नहीं पढ़ा रहा अभी, एनर्जी बाद में पढ़ेंगे. फर्स्ट ऑफ ऑल विल गो थ्रू द फर्स्ट वन, दैट इज मैकेनिकल पावर. सो वी आर गोइंग अहेड विद मैकेनिकल पावर, राइट? व्हाट इज मेंट बाय मैकेनिकल पावर? एवरीबडी रिमेंबर्स दिस. कहते रेट ऑफ डूइंग वर्क. व्हाट डज इट मीन? रेट ऑफ डूइंग मैकेनिकल वर्क. व्हाट इज द मीनिंग? See, measure the work with respect to time, that is amount of work done. P is given as the small amount of work done divided by the small amount of time. So amount of work done in a given time interval, that is power, right? Example, suppose I take up this notebook and किसी ने मुझे बोला कि there are 500 notebooks, ऐसे 500 notebooks हैं और इसको उठाकर कबर्ड के टॉप पे रखना है. तो आई हैव टू मेथड्स. अगर मैं थोड़ा सा आलसी हूँ तो व्हाट आई विल डू, आई विल टेक अप वन नोटबुक, आराम से रखा वहाँ पे, फिर अनदर वन, आई विल टेक माई टाइम, सेकेंड वन, देन थर्ड वन, आई विल टेक माई टाइम, कीप इट देयर. तो आई एम एक्सिक्यूटिंग द वर्क स्लोली, यू नो. आई एम अगेन एंड अगेन लिफ्टिंग द सेम मास, यू सी, mg or weight. I am again and again lifting the same weight by applying the same amount of force. I am displacing it through the same amount. Yes, that means work done in all the cases the same. But you see, I am executing this slowly. So I have two methods to do that. मुझे कहीं जाना है तो मैं जल्दी जल्दी करूँगा, हाँ. मुझे कहीं नहीं जाना है तो मैं आलसी हूँ, मैं आराम से करूँगा. So I have two methods to execute the same process. I can take a large time interval to execute the process. I can take a small time interval to execute the process. What if I am taking a large time interval in doing the work, dW? If time interval is large, power is small. The amount of power developed is small. और जल्दी जल्दी करें तो time is small, power is large. So large amount of mechanical power is required if you execute the same work but in a smaller time. But a smaller amount of power will be required if you execute the same work in a larger time interval. The choice is yours, right? So that is what is meant by rate of doing work. समय कितना लेते हैं आप किसी पर्टिकुलर काम को करने में, उसको कहते हैं मैकेनिकल पावर. ठीक है? बोले ये तो पढ़ा था सर हमने, कुछ नया है क्या 11th में? हाँ एक है, देखिए. So this being the primary definition, यहाँ पे एक चीज़ बता दूँ, ऐसा नहीं कि we are simply going to neglect this. This is an important one because it tells us the SI unit of power, that is joule per second, also known as, this is equivalent to watt. We call it as watt, na? So when 1 watt of mechanical power is done or developed, then 1 joule of work is done in 1 second of time. यदि आप 1 जूल ऑफ वर्क 1 सेकेंड में करते हैं तो जो मैकेनिकल पावर रिक्वायरमेंट होगा या डेवलप होगा, दैट विल बी 1 watt. देयर आर सम लार्जर यूनिट्स ऑफ watt, you know. You call them as megawatt, equivalent to 10 to the power 6 watts. Call them as kilowatt, से पढ़ा है आपने, 10 to the power 3 watts. Megawatt हो गया, gigawatt 10 to the power 9 watts. These are common ones, ना? So I have written these. ठीक है? बोले what is the dimensional formula of the power? So dimensional formula of power can be found ना, as per its mathematical formula. Work done, ml square t minus 2 is the dimension, ml square t minus 2 divided by time t, that is ml square t minus 3. So this is the dimensional formula of power. So the first form of mechanical power gives you a formula, gives you a SI unit, and gives you the dimensional formula. Can we develop another form? Yes, we can. And that is, see, I'll take up this primary formula again and write it as d by dt of W. ये क्या है? ये तो वही है ना जो ऊपर लिखा है. Now what I'll do is d by dt of, what is work done? Force dot displacement. F dot S. Work done by definition is F dot S. Now F, the force vector remains constant. So anything that is constant won't be differentiated. It will be taken out. Therefore P becomes F dot ds by dt. What is ds? Displacement of the body. What is dt? Time interval. By definition, ds by dt is velocity, isn't it? So the formula becomes F dot V, or simply Fv cos theta. So you can find the mechanical power using this second relationship also. And that also explains why power is scalar. This formula also explains why the power is scalar. I'm sorry, the power is a scalar because it is expressed as a dot product of two vectors, that is force and the velocity vector. So power is scalar. Remember two things. Power can be given by formula number 1 dW by dt, or can be given as F dot V, that is simply Fv cos theta. Now suppose there is an object. Suppose there is an object which is being pulled up on the inclined plane by applying a force F with a constant velocity, say V. So what is the power developed? You can see power developed will be Fv cos 0 degree. Why 0? Both force vector and velocity vector, they are in same direction. Since cos 0 is 1, therefore power is Fv. सही है? बोले हो गया? नहीं. What is the value of force? Has to be obtained. See, if the object is moving with a constant velocity, then find the component of the weight opposite to the force. So this is mg sin theta, and perpendicular wala component nahi likh raha, that is no longer required. You know, in this direction you'll have the normal reaction, and opposite to the normal reaction what you'll have is mg cos theta. Means if weight is resolved in two parts, you'll get this one as mg cos theta, but that is no longer relevant to this question. So not a compulsion, don't go into it. Means what I've done is, weight has been resolved into two components along the inclined plane, perpendicular to inclined and parallel to inclined. We get the sine component parallel to inclined, and we get the cos component of weight perpendicular to inclined. Now if the body is moving parallel to inclined with a constant velocity, then we know that your F equals to mg sin theta. So in the process, what is the power developed? It is mg sin theta, put the value of F, multiplied by velocity V. Multiplied by velocity V. ये ठीक वैसे ही है जैसे सपोज करिए मैं कहता हूँ आपसे कि दिस इज अ मास से m. I am lifting this mass up with a constant velocity of 20 meter per second. So what is the work done? Just go for the force against which I am trying to do the work. I am trying to do the work against force of gravity, that is mg. तो mg के अगेंस्ट इसको उठा रहा हूँ मैं, ठीक है? तो मेरा फोर्स कितना होगा? कम से कम उतना तो होना चाहिए, नहीं तो mg इसको समझ गए. तो अप्लाइड फोर्स इज mg इफ द वेलोसिटी इज कांस्टेंट. बोले आपका फोर्स ज़्यादा होगा तो एक्सेलरेशन हो जाएगा ना, तब थोड़े ना F डॉट V लगाओगे, बिकॉज V विल चेंज कंटिन्यूसली. हाँ, so if I am applying F equal to mg, I can lift up this object with a constant velocity. So if I am doing that, my force is mg and the velocity v that is given, उसको multiply करिए, power developed मिल जाएगा. You have to do the same on the inclined plane for a vertical surface or for a horizontal surface. ठीक है ना? So this is what you have to do throughout for power. This was just a highlighter. This was just a highlighter of the type of numericals that you may encounter. Now moving on to our another section, that is energy. Again, I'm talking about mechanical energies. Remember that. Energy, though, it has so many forms, na? Energy can be light energy, heat energy, किसी भी फॉर्म में हो सकती है. Rotational kinetic energy of molecules, the translational kinetic energy of molecules, the electrostatic potential energy, and so on. Magnetic energy, बहुत सारे forms हैं, infinite. But what we are talking about is the mechanical energy. How many forms of mechanical energies do we have? Two forms. You all know. The one that arises due to the state in which the body is, due to state of body, is the potential energy. Well known, the symbol is capital U and the formula is mgh. With respect to, we call this as gravitational potential energy. बोले ये potential energy का formula कहीं भी लगा सकते हैं? नहीं, कहीं भी नहीं लगा सकते. आप mgh लगा सकते हो when you're talking about gravitational potential energy. When you're talking about the interaction between body and earth, so with respect to earth's surface, the height to which you have raised the body, then you'll be using the formula U equal to mgh. बोले अच्छा, फिर कहीं और कोई और formula? जी हाँ. Suppose you're talking about a spring. This is known as gravitational potential energy. मैंने कहा ना, states तो body की कई सारी हो सकती हैं. In this state, body is under the interaction between, there is interaction between earth and the body. So due to that interaction, the energy in which the body is known as gravitational potential energy, given by mgh. Now, if I talk about a spring, you compress it or you elongate it by amount x. The potential energy is given by half kx square. This is known as spring energy. This is known as spring energy. What is k? Previous video देख लीजिए, उसमें बताया इसको मैंने. Spring constant. Meaning of this, work per energy, first video, उसको देखिए please. X, elongation और compression. How it is measured? Again, first video देखिए. कोई तो कारण हो ना, सारे वीडियो देखो. So x is the elongation or the compression. बोले अगर हम करें नहीं elongation या compression तो spring energy develop नहीं करेगा. क्यों करे? State नहीं change हुआ ना, तो spring energy क्यों develop करेगा? समझ रहे हैं आप मेरी बात? That means if the spring develops some amount of energy, so it has to be elongated or it has to be compressed. Because while doing so, you are doing work upon the spring. प्रेस कर रहे हैं कंप्रेस करने के लिए, तो यू आर डूइंग वर्क ऑन द स्प्रिंग. दिस वर्क डन ऑन द स्प्रिंग इज स्टोर्ड एज इट्स पोटेंशियल एनर्जी. फिर बोले खींच रहे हैं, तो अगेन यू आर डूइंग वर्क ऑन द स्प्रिंग. फर्स्ट वीडियो देख लीजिए, उसमें आपको पता चलेगा. इफ यू ट्राई टू इलोंगेट द स्प्रिंग और इफ यू ट्राई टू कंप्रेस द स्प्रिंग, इन बोथ द केसेस यू डू वर्क ऑन द स्प्रिंग. एंड कितना वर्क होता है? वो हाफ के एक्स स्क्वायर होता है. तो जितना वर्क आप स्प्रिंग पे करते हैं, वही वर्क स्टोर हो जाता है उसमें. किस फॉर्म में? पोटेंशियल एनर्जी के फॉर्म में. समझ रहे हैं आप मेरी बात? तो अगेन द पोटेंशियल एनर्जी इज गिवन बाय हाफ के एक्स स्क्वायर. तो इट डिपेंड्स अपॉन द स्टेट.